Subtracting integers. Let's look at the example 8 minus 2 equals 6. Since 8 is positive, we need to travel to the right 8 steps. So from 0, we'll move 1, 2, 3, 4, 5, 6, 7, 8, landing us at 8 on our number line. Next, instead of moving 2 to the right 2 spaces, as in addition, subtraction moves in the opposite direction. So if addition was 2 to the right, we're actually going to be moving 2 spaces to the left. From 8, we would move 1, 2. That would arrive us at 6, so our answer is 6. How would we show 3 minus 8? Well, along the same lines, let's look at our number line. As in the last example, we would start off going 3 to the right. So from 0, we would move 1, 2, 3, arriving us at 3. And then because we're subtracting, instead of moving positive or to the right 8, we will move to the left 8 from 3. Moving 1, 2, 3, 4, 5, 6, 7, 8, arriving us at negative 5 on our number line. Therefore, 3 minus 8 equals negative 5. How would we show negative 4 minus 6? Now we're throwing in our negative integers. Well, we have to remember that negative 4 is shown going 4 spaces to the left. Subtracting 6 takes us 6 more spaces to the left. So let's start with our negative 4 on our number line would go from 0, or start from 0, moving 1, 2, 3, 4, arriving us at negative 4. And then we will move an additional 6 more spaces to the left, 1, 2, 3, 4, 5, 6, arriving us at negative 10. Therefore, negative 4 minus 6 equals negative 10. The most potentially confusing case is subtracting a negative integer. For example, how would we show 1 minus negative 6? Well, looking at our number line, we're still starting at 0, and first we would go 1 space to the right because of the positive 1. That would arrive us at 1 on the number line. We are then adding negative 6 spaces. That would take us to the left, but we're not actually adding negative 6. We're subtracting a negative 6. So we must do the opposite since we're subtracting, moving 6 to the right still. So from 1, we're going to move 1, 2, 3, 4, 5, 6, arriving us at a positive 7. Almost subtracting a negative moves to the right. So 1 minus negative 6 equals 7. Again, we can see that 1 minus negative 6 equals 7. But when we subtracted negative 6, it was the same as adding positive 6. This is because negative 6 is 6 spaces to the left, so when you go in the opposite direction, you're really going 6 spaces to the right. It's the same as adding 6. This looks like almost plus 1 plus 6, because 1 plus 6 would also give us an answer of 7. In both cases, we end at 7 on the number line. Subtracting a negative number is the same as adding a positive one. And we have the very helpful saying, 2 minuses make a plus. So we use that all the time when we are subtracting a negative, because to us, the addition makes more sense if we're moving to the right. So here's another example. How would we show negative 7 minus negative 9? First, from 0, we would go 7 spaces to the left, 1, 2, 3, 4, 5, 6, 7, arriving at negative 7 because we're adding negative 7. And if we were adding negative 9, we would go 9 spaces to the left, but since we are subtracting negative 9, we must go in the opposite direction, which is 9 to the right. Ooh, it's a little confusing even saying it, but looking at it that way, from the negative 7, we would move 1, 2, 3, 4, 5, 6, 7, 8, 9, arriving us at a positive 2. Therefore, negative 7 minus a negative 9 equals 2. And again, this is a little confusing, so let's look at this another way. Instead, we can rewrite the negative 7 minus negative 9. Let's change that, right? 2 minuses make a plus. Let's change those to the plus. Changing the problem to be negative 7 plus 9. Since subtracting a negative number is the same as adding a positive one. And this should yield the same answer. Let's check. If we start at 0 and move 7 to the left, we're adding a negative 7. 1, 2, 3, 4, 5, 6, 7. We arrive at negative 7 on the number line. And now we're adding 9. Adding simply means we're moving to the right. So from negative 7, move 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. And we still get our positive 2, a much shorter explanation than when we subtract a negative.
Is subtraction commutative? Subtraction would be commutative for two different numbers, a and b, if a minus b were equal to b minus a. So ask yourself, is that true? Go ahead and test with some numbers and discuss with your group. So if we look at some numbers to test, let's just arbitrarily pick that. For example, let's say a equals 4. And I'm going to arbitrarily say that b equals 5. I'm picking two different numbers to represent for a and b. So if subtraction were commutative, we would first need to see a minus b, which in this case is 4 minus 5, which is equal to negative 1. If subtraction were commutative, we really hope that b minus a now equals negative 1. Well, b minus a is 5 minus 4, but 5 minus 4 equals positive 1. Now, negative 1 does not equal positive 1. So, in general, or for this example still, 4 minus 5 does not equal 5 minus 4. So now, generally, a minus b does not equal b minus a. In fact, subtraction is not commutative.